Hello, everyone, and welcome to the sixth session of the massive open online course for the University of Nicosia's master's degree in digital currencies. This is Andreas Antonopoulos, and I'll be answering your questions from last week's material, which was alternative uses of the blockchain. As always, jump into the chat room on YouTube, ask me live questions, follow-up questions as we go through this material, and let's kick it off right away. Ben asks, how do you present on a blockchain as proof of ownership if you want to send, say, a car title to someone you sold the car to? And how are miners paid for confirming that transaction? Ben, that's a very good question. One of the big distinctions that we see in the use of blockchains for recording assets is the difference between intrinsic assets and extrinsic assets. So intrinsic assets are assets that live on the blockchain itself. They have their entire life cycle on the blockchain. So Bitcoin is an intrinsic asset. Ether is an intrinsic asset. Your car is not an intrinsic asset. Those are extrinsic assets. They're assets that are outside of the blockchain. They have perhaps a physical presence outside, or they don't have a physical presence. They have a virtual presence, but outside the blockchain. Let's say a certificate of IBM shares, or a bond, or a certificate for gold, or something like that. So extrinsic assets can be tracked on the blockchain, but one of the challenges when you're tracking an extrinsic asset on the blockchain is that all you're tracking on the blockchain is some kind of reference to it, a serial number, or some kind of proof of ownership that you may trade online using a blockchain. But of course, that isn't the asset itself. And bridging that gap between the blockchain and the physical world can be quite difficult. You know, we've seen in the past that when assets are traded as certificates that represent real assets stored somewhere else, sometimes what happens is the real assets are not properly audited and recorded, and you end up with a real asset being sold twice to two different people, or a certificate being sold and the asset isn't actually in the warehouse. That process of selling something that is held in custody against it is called hypothecation. We've seen that have a lot of problems in the gold markets, for example. And there are some very strong indications that a lot of the collateral used for balance and loans in China, and probably many other countries, the collateral doesn't actually exist in many cases. There have been many scandals where investors who have invested with guarantees backed by some collateral, let's say, for example, an amount of steel or copper or something like that that's held in a warehouse, then discover it's not actually there. So it's very difficult to link the physical assets with the blockchain. And one example of that would be a car, right? So you can trade the certificate that says you own the car, but what does that do to the car itself? And so one of the things we need to consider is how much we can connect the two. One possibility, for example, is that the car has an intelligent locking system that allows it to interrogate the blockchain and find out who its current owner is. And so you can basically walk up with your smartphone and, using the digital key that shows that you own the car, tell that to the car and essentially have control over it. So that's a slightly closer tie to a physical item than you might see with other physical items. So these are some of the challenges you have to deal with when thinking about trading assets on a blockchain. Next question. Natalia asks, what is the difference of storing, for example, an instance of a Bitcoin transaction or a smart contract transaction like real estate leases? Do the addresses look different? And in what way are they discerned? Yes, in fact, they do look different. And in order to store something like a real estate lease, let's say on the Bitcoin blockchain, because that was the reference in your question, you would use some layer that gives you the ability to establish an asset. That might be something like Omni or Counterparty or colored coins. And within those platforms, they may use a different address system in order to be able to distinguish between transactions that contain Bitcoin and transactions that are sending assets recorded in counterparty omni-colored coins, etc. For user interface perspective, it's important to be able to differentiate between a transaction that's sending Bitcoin and a transaction that's sending, say, ownership of a car or a house. Of course, a lot of these smart contracts are not traded on the Bitcoin blockchain. They're traded on Ethereum and other blockchains that are more specialized for doing various types of assets and tokens. But certainly you can do it on Bitcoin as well. Joya asks, if you create a counterparty coin, are you registering the name of the coin with a counterparty XCP extension? So that name is not really reserved outside of counterparty. Is that correct? Yes, that is correct. Most of the Metacoins and various ways of recording assets do not store the metadata directly in the blockchain. Or sometimes they do store the metadata, but not all of it. They might have a link to an external service, such as a file server, an HTTP service, or perhaps on more recent evolutions, an IPFS or decentralized storage system, so that you can look up the information about a specific token. There might be an ID or reference to that token on the blockchain, but most of the other metadata is usually stored off the blockchain itself. And the name is only reserved on the servers that you use to create that particular token. And that's going to be quite an interesting conundrum coming forward. How do you differentiate between a token being traded on counterparty, the same token name being traded by someone else on Omni, the same token name being traded by someone else as an Ethereum ERC20 token, et cetera, et cetera, et cetera. Namespace, that's a problem. Namespace, really the idea that we will use a global namespace to recognize these tokens, but they're only recorded locally, can cause some potential conflicts and some disputes and liability. What is the reason why the storage coin moved over to the Ethereum blockchain? I don't know the specific reason why storage did that. I assume it has to do with the ability to have more flexible programming of their token, the ability to leverage more flexible and rich, expressive smart contracts, as well as perhaps in the early stages of the storage coin, the ability to do so with lower fees because the Ethereum blockchain, at least in the past, had lower fees than Bitcoin. I think in some cases now, Ethereum is also quite expensive, and Bitcoin has gotten a bit cheaper since SegWit for transaction fees. So we'll see. But I think those are some of the motivations for the storage team moving over to the Ethereum blockchain. Third question from Joya. Is Tokenly a valid way to trade and crowdfund these tokens, coins created via counterparty? Yes, I believe Tokenly does support counterparty tokens as well as a number of other tokens, but I think they are also moving primarily to Ethereum. Let's see if we have any follow-up questions in the chat room before I move on to some of the other questions from the forums. Giovanni asks, as a follow-up, do you think implementation of smart contracts on the Bitcoin blockchain may require a Metacoin or a new Bitcoin Core implementation, which may require a soft or hard fork of the Bitcoin blockchain? Possibly, yes. There are a number of suggestions on how to introduce more expressive smart contract capabilities within the Bitcoin blockchain. One such proposal is to connect it to another blockchain via a system called a drive chain, which is a two-way connection between the Bitcoin blockchain and this other blockchain. And that's the proposal that Rootstock brings, which is to run an Ethereum virtual machine on a blockchain that can be fueled by Bitcoin through essentially a sidechain implementation. And that, again, would be a soft fork to enable the sidechain function broader than just smart contracts. All right, let's go back to the forum questions. Ahmed asks, what is your opinion on patents, copyrights, and trademark protections recorded on the blockchain? You know, Ahmed, I'm not sure what problem exactly we're solving. And this is a challenge that many people face when they first come across blockchain technology. They don't know how to identify which applications and uses are appropriate for a blockchain and which ones are not. And of course, there is a tendency, especially in technology circles, once you have an effective hammer in your hand, to treat everything like a nail, as the saying goes, meaning that if people see the blockchain primarily as a database application, they try to find anything that might fit that blockchain model, and all kinds of applications that, in fact, may not be suitable. When it comes to blockchain technology, my approach is to look at the fundamental capabilities delivered by an open public blockchain and to think about whether my project needs those capabilities. So what are those capabilities? Open blockchains are open for access for anyone. They are global and borderless, so they operate across the world without any restrictions or jurisdictions. Or across all jurisdictions. They are neutral, which means that the processing of transactions does not depend on vetting or authorization. It depends purely on whether you follow the rules of validity, the rules of consensus for each blockchain. Blockchains are censorship resistant, meaning that once you've decided to make a transaction, it's very difficult for someone to stop you from making that transaction, almost impossible. They are immutable. Once a transaction has been recorded, it cannot be backtracked. Now, I don't know whether the patent, copyright, and trademark systems we have today are really something that requires any of those features. The real issues around intellectual property regulations are not really about being able to correctly record and retain an immutable record of who has a patent, copyright, or trademark. In fact, that's not the problem. The problem is the exact opposite. In many cases, especially with copyrights, we have no idea who the original holders are because they're not required to register. And copyrights effectively become orphans. No one can use them because no one can track down who the original owner is. And they remain under copyright protection far past the death of perhaps the creator. Also, patent, copyright, and trademark laws are extremely fragmented around the world, which means that they are very closely bound to jurisdictions and borders. A borderless network, how does that reconcile all the different regulations? And finally, you can't really enforce protections for digital rights management with a blockchain any more than you can enforce it with any kind of database of digital rights management, as long as we have general purpose computing devices. And I certainly will not allow anyone to take those unless they take them from my cold dead hands. General purpose computing devices are the basis of our modern information society, and general purpose computing devices cannot be locked down in such a way that you can enforce digital rights management. Because it's always possible to change the software, and on devices like that, bypass the DRM. So having all of that recorded in a blockchain, I don't know that that actually solves anything. So that's how we should think about it. On that note, let's go to the next question. Abdelkrim asks, what is your opinion on blockchain solutions for voting and online teaching? All right, let's run through that exercise again. Which part of open, borderless, transparent, neutral, censorship-resistant, and immutable is necessary for voting? And it's an interesting question because there are some circumstances in which the ability to accurately record either the right to vote or the vote itself on a blockchain might be very useful to prevent tampering with a vote after it has been cast. Although, of course, the countries in which that's a problem tend to also have a very low level of technology use and adoption, especially around blockchains. So how do you make this broadly available to a broad population? Call me old-fashioned when it comes to voting. My preferred technology is paper, pencil, and auditable recorded ballots that can be viewed by lots of people who have competing interests with a system of checks and balances. Old school. It is actually very difficult to commit broad-based voting fraud when you have observers who can record ballots cast on paper with pencil. Voting machines, digital kiosks, technologies like that, punch cards, OCR, they open the door to all kinds of hacking and mischief. They don't leave good auditable records and paper trails. And they cause problems for voting, actually making it easier to commit voting fraud. And quite honestly, in most developing countries, voting fraud is not the problem. Voter apathy is the problem, and you don't solve that by making voting more complicated. So again, we have to be careful not to try to apply blockchain technologies to whatever problem we find in front of us. Online teaching, great. What part of an open, borderless, censorship-resistant, neutral, accessible, permissionless, transparent, and immutable blockchain applies to online teaching? It depends what you're teaching. Well, perhaps there are some things you need to teach that are censored, or something like that. But I see that as a very narrow niche. So in terms of online teaching, I guess, is very much about a lot of content and interaction, and I don't see how a blockchain will help with that very much. Let's see what else. Rolando asks, could other cryptocurrencies other than Bitcoin or Ethereum be used, or Ether be used by participants of a solar energy blockchain-based network to facilitate transactions? Yes, Rolando. In fact, I believe there are already several, I would say at least 2 other blockchains that I know. I can't remember their names right now, probably called something like Solar Coin or Shine Coin or something like that. But there are blockchains that are specialized in order to look at either alternative energy or, more specifically, solar energy, which brings up another interesting question. If you have a new application and you really do need a blockchain for it, what do you do? Do you build a new blockchain just for that application? Do you use a general purpose blockchain, such as Ethereum, to code your application as a smart contract or token? Or do you use Bitcoin's secondary layer, Metalcoins, like counterparty omni-colored coins, to implement your solution? That's a very difficult choice to make, and it has long-term implications and some very important trade-offs. Those trade-offs involve whether you can actually secure a blockchain if you build your own, who's going to mine it, how the consensus is going to work, can you make it robust enough that it can withstand interference, perhaps an attack against the consensus layer, can you make it secure enough to protect the assets that are being managed by that blockchain so that it can scale, can you make it efficient, is it worth implementing all of that from scratch? Honestly, over the last year, I think the answer to that question has increasingly been no. And as a result, we've seen that the vast, vast majority of new applications are built on a general purpose blockchain like Ethereum, specifically on Ethereum, in order to take advantage of the smart contract capability, so as not to have to reinvent the security, mining, consensus layer, and all of the other things that Ethereum gives you right out of the box. And of course, that was exactly the purpose for Ethereum, to provide the general purpose platform so that other applications didn't have to invent their own blockchain. You can do it. The question is, should you? And that's where things get interesting. Ashish asks, are Bitcoin miners and validating nodes affected by Metalcoins? Ashish, no, they're not. In fact, this is, again, one of the interesting design trade-offs that happen when you're choosing where to build your application. Metalcoins that operate within the blockchain, the Bitcoin blockchain, operate using data fields like op return and other ways of embedding data within Bitcoin transactions. They incur Bitcoin fees, but the validation of what's happening in the Metacoin layer, whether the counterparty token is correctly registered, whether you have that counterparty token, for example, or the Omni token, whether it's a valid transaction from the counterparty perspective, all of that is invisible to the Bitcoin miners and validating nodes. It's only validated by counterparty nodes, and they don't control the Bitcoin mining. When I first discussed Ethereum with Vitalik Buterin, in fact, my very first question was, Why build a separate blockchain and not an extension to Bitcoin? And the primary argument that Vitalik persuaded me with was because a separate layer within Bitcoin means that the smart contracts themselves are not part of the consensus rules validation. And that means that all of the security to Bitcoin stops short of the important data that you want validated for the smart contract. And that was a very persuasive argument, which actually made me quite interested in Ethereum. And it gave me a reason to understand why Ethereum would need its own blockchain. So in Ethereum, the smart contract is validated as part of the consensus rules by the miners. But a counterparty token transaction on Bitcoin is not validated by the Bitcoin miners. So while you have some of the security mechanism and protection of Bitcoin, you don't have all of it. And that's, again, a critical design consideration when choosing where to build your application. Kingsley asks, what is the meaning of blockchain timestamping and publishing of messages? Kingsley, one of the really useful capabilities of blockchains is timestamping. In fact, if you read the original Satoshi white paper, he describes the function of mining as a decentralized timestamping service that allows you to create a timed ledger of the transactions. Timestamping and ensuring that those timestamps are within a margin of accuracy and broadly accepted, and building consensus around these timestamps is, in fact, one of the core services of the Bitcoin blockchain and really any blockchain. Timestamping allows you to ensure that you use the immutability function of a blockchain, such as Bitcoin's blockchain, in order to be able to create a proof of existence. A proof of existence is basically timestamping a fingerprint or hash of, say, a document, so that you can later prove that on or before that date, that document existed. And you can do that by presenting the document, allowing someone to calculate the hash, comparing it to the hash that has been embedded with a timestamp in the blockchain. And they can say, yes, this hash could only have been embedded in the blockchain if the person who created it had this document at that time. Why? Because you cannot find the pre-image to a hash function. It's computationally infeasible. So that guarantee means that you can prove that that document existed either on the date where it was timestamped or before the date that it was timestamped. Think of it like when you do a video and you hold up a newspaper and show a headline on the newspaper, and that proves that that video could only have been taken after that newspaper was published. Well, timestamps are kind of the opposite. You're showing that a document existed on or before. Christoph asks, do you know why the MedVault project, which does medical records, uses the Colu digital asset platform instead of developing their fully autonomous blockchain? I do not, but I would hazard a guess, and that is that in many cases, as part of the design trade-off of whether we should build a new blockchain or simply use existing techniques like Metalcoins, even if they're not quite as capable, it would make sense to do an initial prototype on an existing system, because that means that you can get to having a minimally viable product or prototype to demonstrate a lot sooner. You know, these platforms give us a lot of flexibility, and if we're trying to build a new blockchain for a specific application, that means redoing everything, and that's a lot of work. So faster time to prototype is basically my guess about why a lot of projects might use a platform to build on, such as a Metacoin, a colored coin, or Ethereum, instead of using their own blockchain, even if eventually they're going to need their own blockchain for whatever reason, for whatever design consideration. Julian asks, is there a case for creating a new blockchain with the purpose of issuing academic certificates, or would it be wiser to reuse an existing blockchain? Julian, in my opinion, it would be wise to use an existing blockchain that has ample security behind it and very strong immutability, specifically the Bitcoin blockchain. Issuing academic certificates is effectively a very simple timestamping proof of existence application. You can use a protocol like open timestamps in order to record the certificate of each student once they pass. In fact, that's exactly how this course awards the certificates and records them on the Bitcoin blockchain. Those certificates then are protected by the full immutability of the Bitcoin blockchain, backed by all of the energy that goes into mining that ensures that it is impossible to reverse those transactions. Within 6 blocks or more, it becomes impossible to reverse those transactions. So academic certificates are a great application for timestamping, proof of existence, open timestamps, protocols like that. And there is absolutely no reason to build a new blockchain for that. Even if you didn't want to do it on the Bitcoin blockchain, there are blockchains specifically dedicated to recording facts. Factum is one of those, so you could use that. Really no reason to build a new blockchain. Let's see, what else? Do Metalcoins require you to spend Bitcoins, and how do the fees of Metalcoins work? Great question from Ashish. Thank you, Ashish. Metalcoins, yes, they do require you to spend Bitcoins, and they do have fees. Why? Because a Metalcoin transaction is a Bitcoin transaction. It's a Bitcoin transaction that carries some data. And that data, well, it takes up some space. And because Bitcoin transactions are charged by their weight, and the fee is calculated based on the size of the transaction or weight of the transaction in bytes. When you put the data that tells the counterparty or Omni or Cola protocol what you're doing, that data will take up some space in the Bitcoin transaction, and you will have to pay a fee. And that's why you do need to spend Bitcoins to use Metalcoins. Let's see what's next. I'll check some questions on the chat room. Let's do some follow-up questions from there. Eamon asks, how can a blockchain solution be public when it is only business to business? What is the exact definition of public? As far as I'm concerned, Eamon, the interesting blockchains are the open public blockchains, ones that are accessible from anywhere by anyone without authorization and vetting. So how can that be when it's a closed B2B system? Well, quite simple. It's not public and it's not open. And as a result, many of the other fundamental capabilities of open public blockchains go away. If it's not open and it's not public, its consensus layer cannot be participatory, which means that it's centralized and controlled by one or more entities. Those entities immediately have a legal responsibility over the content of those transactions, and they're identifiable. And as a result, it's not censorship resistant or neutral. It cannot be. It's also not immutable. So you went from having an open, borderless, neutral, censorship resistant, and immutable blockchain to a blockchain, which is really just a database, which is really just a very slow database and doesn't have any of those key capabilities. Why would anyone do that? Well, I don't quite understand that yet, but it's funny, after 20 years of learning that the open public internet is the real place of value, people still do intranets. And it appears that many corporations are still struggling with the idea that things that are open and public are more secure than things that are closed and private. Giovanni asks, do you think the implementation of smart contracts on blockchain may require... Oh, no, I've already answered that. I apologize. Let's keep going. Fernando, blockchain for ID verification. What do I think about blockchains for ID verification? I am extremely skeptical of using blockchains to implement identity systems for a number of reasons. First of all, in order for it to be interesting, it would have to be decentralized. And most everything I have seen at the moment is not decentralized. Part of the reason for that goes back to what I was talking about before, which is the difference between tracking things that are intrinsic to a blockchain and tracking things that are extrinsic to a blockchain. And guess what, Fernando? Fernando is an extrinsic asset. You are not part of the blockchain. Andreas is an extrinsic asset. I am not part of the blockchain. So if I'm tracking an Andreas identity on the blockchain, how do I connect or attach the Andreas identity on the blockchain to Andreas, the actual physical entity off the blockchain, and make sure that that connection is unique, it's unforgeable, it's probably verified? Usually that means having a trusted party to do that verification, which then throws away pretty much all of the benefits of blockchains. Furthermore, now you have a record that is sitting on an open, public, transparent blockchain that is immutable. What happens when that record is compromised or stolen, or you lose your keys? Oops, you have a very big problem. Some people suggest using biometrics. And that further weakens the security model because, of course, you can't change your biometrics. So that's not a good solution either. And one of the basic ideas of a blockchain is that it never forgets. It is immutable. I'm not sure I want to build identity systems for humans that never forget. That sounds like a fascist dystopia to me. But this is a broader discussion, which we're going to be talking about for many, many years. I'm sure people will implement a lot of different identity verification mechanisms. Here's the real kicker, though. What Bitcoin has demonstrated over the last 9 years is that for the first time in history, we can implement trust without identity. Until now, nobody thought that those two things could be separated so cleanly. Yet in Bitcoin, we can do trusted transactions with people whose identity is completely unknown. And we can trust transactions from people whose identity is completely unknown. And that allows us to do something really novel. So the question is, what do you need identity for? And if the answer is I need it for trust, Bitcoin's answer is no, you don't. Patrick asks, how can we connect two private blockchains so they can communicate documents, money, etc. to each other? Well, let's look at our experience from the internet. How do you connect two intranets together? Via the internet. And so how do you connect two private blockchains together? Via an open public blockchain. Of course, once you realize that, then it quickly becomes evident that the most valuable property is the open public blockchain, and the private blockchains on their own are not so useful after all. So then why do you have a private blockchain? It's less secure, it's less transparent, it can't be open, borderless, censorship resistant, neutral, or immutable. And now you're also connecting it to a public blockchain to interoperate it with another private blockchain. So what exactly did you achieve? And again, that's a question that a lot of companies are struggling to answer right now, which is why we see a lot of these prototypes for closed private blockchains not really delivering any results. They very quickly discovered that what they've built is a very slow database. Sasha asks, is a blockchain-based artificial intelligence more securable than one without decentralized capabilities? Could this be the solution to the threat of a super intelligent AI? That's probably a bit outside of the scope, but I do find that an interesting question. A lot of people are talking about putting AI on the blockchain, which I don't think is really a viable application anytime soon. And I'm not sure what it means. I'm more interested in decentralizing AI and connecting it to blockchains so that you can have various other capabilities, like introducing immutability. But it's not a solution to the threat of a super intelligent AI if you believe the Elon Musk and Hawking and others who have talked about this problem. Because sure, if you build your AI on a blockchain and constrain it and make it decentralized, that's great. But that doesn't stop someone else from building a super intelligent AI that becomes post-human, at which point you have that problem again. So just because you choose to build your AI on the blockchain doesn't mean that everybody will. So no, that doesn't solve it. Morris asks, blockchain timestamping on copyrights is like a defensive patent without needing to register. Yeah, Morris, not really, because in most cases, under most copyright regimes, registration is no longer necessary. Upon creation of the work, it automatically assumes copyright. That's my understanding. Of course, I'm not a lawyer. You may use blockchain timestamping simply to make sure that you can prove that the document or copyright existed back then. But there are other ways to prove that too. Timestamps might be a useful thing there. I personally haven't used them. Then again, all of my work is open source, so clearly I don't believe in copyright. Khaled asks, can colored coins and Metacoins be used on the Lightning Network? Fantastic question, Khaled. And the answer is, surprisingly, yes. In fact, the Lightning Network can not only use colored coins, but it can be implemented in such a way that it can become a multi-currency and multi-token Lightning Network, where you open a payment channel, and through that, you route Bitcoin. But across the entire route, at some point, it gets converted, say, to Ether or Zcash or a token or a colored coin or something like that when it's deposited in another place. So essentially, Lightning Network becomes a multi-currency decentralized exchange for multiple tokens. Let's see what else. Christian asks, if an additional layer can be built can build almost everything on top or inside or beside or on a sidechain of the Bitcoin blockchain, why are there so many other coins trying to clone it? Christian, there's two answers to that. There's the cynical answer, and then there's the more serious answer. The cynical answer is because they're greedy. And we've seen this explosion of altcoins in 2014, and now we're seeing this explosion of ICOs. And as I've said publicly many, many times, a lot of them are junk, if not most, if not all. And so why are people building all of these blockchains? I think in many cases because they missed the boat on Bitcoin, or because they want to do something that gets them faster to their imagined riches, or because they see that people are acting irrationally and with extreme exuberance, and it's easy to take their money. So that's one reason. That's the cynical reason. The second reason is that it has to do with design trade-offs and control. There is a tendency among all developers, but more broadly among people, to this tendency is called not invented here, which is the idea that you can do better at inventing something that somebody else has done. And rather than reusing other people's technology, rebuild it from scratch. And you can apply that to different levels. Maybe your application is just a thin layer on top of a lot of other technology built by other people. Or in the extreme case of not invented here, you don't use anybody else's technology and you reinvent everything from the hardware on up. And of course, different companies have tried various strategies with this. And that's why we're seeing a lot of these blockchains. So in order to have full control over the entire software stack and the entire process and the consensus algorithm, you need to build your own blockchain. And some companies believe they'll get the best success or opportunity in the market by having full control. Personally, I disagree, but it's really a choice for each designer. Boulevard asks, does Bitcoin provide 100% anonymity? Oh, that one's an easy one. No. More seriously, though, does Bitcoin provides pseudonymity, and in some cases strong pseudonymity. But in order to guarantee the strong pseudonymity of Bitcoin, you need to have very, very strong operational security and be very, very careful with what wallets you use and how you use them so that you don't taint one address with another, et cetera, et cetera. At the moment, Bitcoin's anonymity is really quite weak from that perspective. And it's fairly easy by connecting to a number of nodes on the Bitcoin network to be able to discern where transactions are originating from, connect those up to accounts that are held on exchanges that are participating in analytics companies, and reveal the identities of users, connect those to the other coins they own, and pierce the veil of anonymity for the vast majority of Bitcoin users. And that's a challenge. In fact, I believe it's probably one of the biggest challenges facing Bitcoin specifically, but also Ethereum, which also is weak in that respect, is how fast it can introduce anonymity and privacy features or fungibility features in the core layer of the protocol. And that means things like signature aggregation, zero-knowledge proofs like Z-snarks, ring signatures, confidential transactions, blinded signatures, et cetera, et cetera, et cetera. All of these techniques, as well as layer techniques like remixers and coin tumblers and things like that that operate by default in consumer wallets, so that everybody has a degree of anonymity that strengthens the herd immunity against surveillance. So we'll see. I think that's a big challenge. We are seeing a lot of work being done in that space. And I hope to see some great improvements in Bitcoin's fungibility. Right now, Bitcoin and Ethereum, as two top examples, have very weak privacy. Joya asks, is Ripple currently successfully using a Lightning network? And you might hear that question, and at first glance, you might go, oh, that's not correct. Ripple and Lightning Network are not the same thing. But if you think about it a bit more carefully, what Ripple does is effectively a network of IOUs being exchanged between federated servers. The difference is that Lightning Network does that, but it does it within Bitcoin transactions that are secured by the Bitcoin consensus layer, whereas Ripple has its own consensus mechanism to secure these IOU responsibilities and is not quite as decentralized as Bitcoin and has a very different security model. But it's not that crazy to think that Ripple is a payment channel network. Because it is a payment. It is a routed payment channel network that uses very similar mechanisms to do its payment routing as Lightning and Raiden and other routed payment channels. So yeah, in some ways, Ripple is using something that looks very similar to a Lightning network. The difference is that the underlying security model and consensus mechanism are very different. Whereas Lightning Network uses the security model and the consensus model of Bitcoin. Let me quickly go over to the chat room and see what other new questions we have as follow-ups. Not yet. No more. OK, and back to the questions from the forums from earlier. Christoph asks about smart contracts and their use in businesses. What do we need to change in our organization? What trade-offs should we consider? And where should we start if we want to switch from a system using dumb contracts and legalese to blockchain and smart contracts? That's a great question, and one that a lot of legal professionals are challenged with at the moment, which is understanding how to marry the world of law with the world of blockchains. Now, part of the confusion here arises out of the very poorly named smart contract, because smart contracts are neither contracts nor smarts. Smart contracts are, in fact, dumb programs. So I think there's a tendency to think of smart contracts and then think of a contract like an employment contract or sales contract and try to find similarities between those two. Of course, you can use a programmable smart contract, such as an Ethereum Solidity program, in order to encode terms and conditions. But the majority of a contract isn't terms and conditions. The majority of the contract has a lot of other things in it, like, for example, important information about jurisdiction and law that you will use, and the mechanism by which disputes will be resolved, et cetera, et cetera. And a lot of that cannot be separated from the broader legal context in which you are. If you're interested in hearing about some ideas there, one of my colleagues has done some great work on a project called DAM, and that's how it's pronounced, DAM, the Decentralized Autonomous the Decentralized Arbitration and Mediation Network. And DAM is a project to connect smart contracts with legalese in order to be able to leverage things like international arbitration and mediation through the New York Convention and other legal constructs, so that you can make whatever smart contract you have the same kind of jurisdictional reach and applicability as a written contract. So this is a tricky area. It's still very early days, but there's some very interesting research in that space. Second question from Christoph is, what do you expect from smart contracts in real-world business transactions? What is blockchain technology capable to offer in this regard? Christoph, I would recommend that you take the word smart contracts and you think of it in a very narrow sense, and then you can actually find some very viable applications today. Let me give you an example. Bitcoin's multisig is a smart contract. And what can you do with that? Well, you can do things like atomic cross-chain swaps. You can do things like escrow for real estate without custodial control of the funds by the escrow holder, or in fact anybody, which are much more secure and much more flexible than traditional escrow through banks. So you can use smart contracts today, as long as you limit your scope of what you call a smart contract and look at some of the things that are really simple, practical, but extremely powerful that you can apply today. Alexander asks, how will smart contracts change the job of lawyers? Will programming skills be essential for a lawyer in the future? This is a great question, and the answer you'll get depends on who you're talking. For some people, the whole promise of smart contracts is that lawyers will no longer exist, and they say that with a big smile on their face. But the truth is that most lawyers are not simply taking templates and composing contracts, because that's not very valuable work. The job of a lawyer is to be able to clearly understand the motivations and interests of their client and protect those interests and express those interests in a way that's effective in a contract. And that doesn't go away if the contract is in solidity, or in fact, more likely if the contract is a mixture of a smart contract implementation and a legal contract that connects to businesses, for example. So good lawyers don't go away. Bad lawyers who simply put contracts together, well, you know, arguably, they've already been replaced in many countries by websites like LegalZoom, which can do it for you. And many people who have a basic level of literacy and education can do the job of a simple transactional lawyer for simple things using these sites. So again, there's a whole spectrum of skills in the legal profession, and some of those skills will be challenged by this, but only the lower scale. And lawyers who are really good at understanding and protecting the interests of their clients, they don't go away. They might have to either learn solidity, or more likely operate in an environment where they work together in partnership with people who can implement things in solidity. Just like a user interface designer works with a programmer and a product manager to bring something to fruition. In the future, of course, smart contract programmers are very likely to be an important part of a law office. But that's not really that crazy to think about, because today, if you go into your average law office, they have a very strong investment in IT in order to be able to do forensics and discovery and evidence management and all of the other things that require management of big data and things like that around computers. Let's see. I think that's all of the questions we had from the forums. Let's see on the live chat, and if you have any follow-up questions, now's the time. Jump in there and send me your questions so I can wrap this up. Carol asks, is it better to have anonymity as a second layer of Bitcoin or in the first layer of an alternative blockchain like Monero? Carol, I'll give you a third answer, and the third answer is to have it in the first layer of Bitcoin. And I don't think it's too late to also do that. It's far better to do it in the first layer and secure all of the other layers above than to try to retrofit fungibility or security in the second layer or above. Look at what's happened with the internet. TCP/IP as a protocol is very weak from a security perspective, especially IPv4. And some of those weaknesses were fixed or attempted to be fixed by IPv6. But we see those weaknesses now have reverberated in the internet over the past 20 years. And a lot of the problems we have is because the core protocol didn't have sufficient privacy and security built in, and a lot of it is implemented above, layers like SSL and DNSSEC and things like that. Whereas other layers within the protocol that are very, very important, like BGP, which is the routing protocol, are almost completely insecure. So you should have it as a first layer. I think we will see a lot more work in the first layer of the Bitcoin blockchain. Is it better to have it as a first layer of an alternative blockchain like Monero? Yes, in some ways that's great, because we're having a lot of competition in the broader space between various blockchains that are specializing in privacy and implementing all different models for offering fungibility, anonymity, privacy protections, the whole spectrum of privacy. But quite honestly, I'd like to see those things implemented in Bitcoin directly. Fred says, what is your opinion of a cryptocurrency pegged to physical assets? Fred, the problem with that, as we've seen in time and time again in many, many different markets, is maintaining that peg. For example, there are world markets where you can trade gold on paper certificates, and these paper certificates are pegged to physical reserves of gold. Are those physical reserves of gold there? We don't know. In fact, a lot of people speculate that the manipulation that happens in certificated gold is huge and is one of the main problems facing the gold markets. And we've seen markets like that be manipulated. So a cryptocurrency pegged with physical assets, again, intrinsic, extrinsic. Cryptocurrency is intrinsic. The physical asset is extrinsic. How do you link the two in a way that is credible, auditable, and automated? And the answer is, so far, we can't. Victor asks, what future development of smart contract programming will possibly help avoid unexpected side effects of the smart contract code? Victor, that is a great question. Unexpected side effects of smart contract code at the moment are a big, big problem. And this has to do with a number of different things. One of it is just simply maturity, right? We're still in the very early stages of this technology, and a lot of the tools are not very mature. The Solidity programming language, the Ethereum virtual machine, and all of the other smart contract implementations you see out there, it's very difficult to write secure smart contracts. In fact, at the moment, it might be near impossible. I'm skeptical as to whether anyone in the industry can write a secure smart contract. Even the people who invented this stuff have written smart contracts that later were found to have very serious vulnerabilities, leading to very large losses. So how do you fix that? One of the ways you fix that is with a particular area of computer science called formal proofs. And this idea is that you use languages that are much more constrained and mathematical in nature, that through the very design of the language allow you to do analysis of the program and to produce proof that the program will behave within a specific range of behaviors. So it allows you to reason about the future behavior of the program. Now, this is not an easy thing to do, but there is a lot of research going on in that particular space. Edwin asks, has any jurisdiction approved the use of smart contracts for business? Well, in many jurisdictions, there is no requirement to approve anything. Two private parties, two businesses can agree to engage in business using a smart contract, and it's nobody's business other than theirs. So private businesses, for example, in the United States and many developed nations, do not require permission to engage in private contracts using new technologies. And so smart contracts can be used. And whether they have validity in law is going to be discovered through disputes, through lawsuits. But I don't see any reason why not. There's an abundance of law in many developed countries that recognize things like digital signatures, electronic documents, electronic execution of contracts, and things like that, all of which tie very nicely into smart contracts. So I don't see any problem with that. Great. And that was, I believe, the last question we had from the forums. As always, thank you so much for coming. Thank you for your great questions in this session. For next week, read the materials, prepare your questions in the forums, and then come join me for the live session and the live chat so we can answer them. This has been the 6th session of the Massive Open Online course for the Master's Degree in Digital Currencies by the University of Nicosia. I'm Andreas Antonopoulos. I'm really grateful you came today, and I hope to see you again next week. Thank you.